Let us continue with exercise 8D trigonometry. Exercise 8D, question number 8.3. We have to prove that the left hand side is equal to right hand side. We are giving here cosec 4 theta minus cosec square theta. In the right hand side, we want cot 4 theta plus cot square theta. 4, we don't have formula, so let us break it as 2, 2. We can put 2 inside, 2 outside. So 2 into 2, 4. Then cosec square theta, for the time being, let it be there. If we check the left hand side, we want only cot. So let's convert them. We want only cot, so let's convert them by using identity. Cosec square theta, from identity we know that it is equal to 1 plus cot square theta whole square, because we have one more square from here. Okay, then here also we can convert the same thing, because we don't want cosec anymore, we want only cot. So in place of cosec, we can convert from identity 1 plus cot square theta. Then here now we can apply the formula a plus b whole square. Our a is 1, our b is cot square theta. So it will be a square plus 2 into a into b plus b square. 1 square from the question, 1 square from the formula. Then this one, let it remain like that first. So here we have 1 into 1, 1. 2 into 1, 2. It will remain 2 cot square theta. Then here 2 into 2, 4. Then this one, minus into plus, minus, minus into plus, minus. Then here we see we have plus 1 minus 1, 1 minus 1 0, we can cancel. Then here we have 2 cot square theta, here we have minus cot square theta. So 2 minus 1, it will remain only cot square theta. Then cot 4 theta, let it be there. Okay, so if we check from the right hand side, we want cot 4 theta plus cot square theta, which we already get. So once we get it, we finish there. So we'll continue next to question number 9. We have sec 4 theta, 1 minus sine 4 theta minus 2 tan square theta. We have to show that it is equal to 1. Let's multiply here. Sec 4 theta into 1 will be sec 4 theta. Sec power 4 theta into sine power 4 theta will be, since both are different, we'll write them both. This one, let it be like that first for the time being. 4, we don't have formula, so we can make it square square. Then the relation, we have sec equal 1 by cos. So here we have power 4, we can write sine, let it be up. Then sec using relation, we convert it to 1 by cos power 4. 1 into sine will be sine. So this one, let it be like that. Then here, because in the right hand side, we want only 1. So let's leave it like that first, okay? Then here, sine by cos. From the relation, we know that it is equal to tan 4 theta, because power is 4. Then now, tan 4, we don't have formula. We can convert it as square square. So here we see square, here also square. Now we can apply the formula a square minus b square. Our a is sec square theta, our b is tan square theta. So we can apply the formula a minus b, a plus b. Then minus 2 tan square theta, let it remain fast like that. Then here, sec square theta minus tan square theta, if you check from the identity, is equal to 1. So that means that part is over. Then we are left with this one, minus 2 tan square theta. Here we have tan square theta, tan square theta. So they are like term. But here we have minus 2, here we have plus 1. So 2 minus 1, it will be minus, since minus is greater. Okay. Then sec square theta minus tan square theta, from identity we know it is equal to 1, which is equal to right hand side. Let us continue with question 10.1. We have 1 minus sine theta, 1 plus sine theta. We have to show it is sec theta minus tan theta whole square. We don't have square, we cannot apply identity. Then we have only sine. So there is no relation as to say. So what shall we do? We will rationalize it. Here we have plus, we rationalize with minus, we rationalize with conjugate. Okay, same number, opposite in sign. So here 1, we 1 sign, here sign, here we have plus, we multiply with minus. Then the one which we multiply here, it's the same one we have to take up. Then now here we have minus minus 1 1 sine theta sine theta. They are same. In the right hand side we want whole square. So what to do? These two, because both are same, we can write them whole square. Then down we have 1 plus 1 minus. We can apply the formula a plus b, a minus b, which is equal to a square minus b square. 1 into 1, 1. So from identity, 1 minus sine square theta, we can say it will be equal to cos square theta. So that we can exchange. Okay, those. Then now here we have square square. So we can take common square because in the right hand side we have square. Then in the right hand side we don't want cos, we don't want sine. So this denominator, let us break it into two parts. So we can write 1 by cos theta minus sine by cos theta. Square we already take common. So far 1 by cos from the relation we know it is sec theta. Sine by cos we know it is tan theta. So we get the right hand side which is equal to sec theta minus tan theta whole square. Similar way you can try yourself tan 2. Okay, next we'll do tan 3. Here also similar. We have 1 plus cos theta, 1 plus cos theta. We have to show this one. So what to do? We will rationalize the denominator. We have minus, so we have to multiply with plus both up and down. Okay, so let us see it. Here also in the left hand side we have no square, but in the right hand side we have one square, but 1 plus 1 minus. So we will rationalize the denominator. We have 1 minus cos theta, we will rationalize with the conjugate. 1 remain 1, cos theta remain cos theta, but instead of minus we will write with plus. Then the one which you multiply down we also take it up. Then up we have same. In the right hand side we want square, so we put them under one bracket to be square. Down we can apply formula a minus b, a plus b. It will be a square minus b square. 1 into 1, 1. So from identity 1 minus cos square theta is equal to sine square theta. Now we have square up and down, we can take common. Then we don't want cos, we don't want sine. So let us separate them. Separate the LCM. So it will be 1 by sine plus cos by sine. 1 by sine from the relation we know it is cosec theta. Cos by sine we know it is cot theta plus whole square. So if you check the right hand side, this is what we want. So we prove. Okay. Then similar way you can try tan number 4. You can try it similar to tan number 3. Then next we will move on to 11 1. Here we have square root, but if you look here we have 1 plus 1 minus. So we'll do with the same method like what we had done here by rationalize the denominator. So this all here also we'll try by rationalize, because we have 1 plus 1 minus, and that also 1 numerator 1 denominator. Next we'll see 11 1. Here we have square root of 1 minus sine theta, 1 plus sine theta, but in the right hand side we want sec theta minus tan theta. So first we have to remove square root. How to remove? We don't have square, we cannot use identity as to say. Relation also we don't have much. So what do? We will rationalize the denominator. Here we have plus, we will rationalize with minus. Same number but only opposite in sign. Then if we multiply here with minus, the same thing we have to take up. Then now numerator we have same quantity, same sign. So we can make them whole square. Down we have 1 plus 1 minus. We can apply formula a plus b, a minus b, which is equal to a square minus b square. Then 1 to 1, 1, sine square into sine will be sine square. So we can use identity 1 minus sine square equal to cos square theta. Now square square we can take common. Then we don't want sine and cos uh, in the right hand side, so we will break the LCM. We can break it 1 by cos, sine by cos. Then from the relation 1 by cos we know it is sec theta. Then minus sine theta by cos equal to tan theta, and this square and square root get cancelled, so it is equal to right hand side. Similarly, it will go with 11 2. We have square root of these, but we don't want square root in the right hand side, so we will rationalize. Here we have minus, we'll rationalize with plus. Then whatever we multiply here down, we'll take it up. Then we have to get root of the square root, so we need square. So here we see both same sign, we can write whole square. Here 1 minus 1 plus, we can apply formula a minus b, a plus b, become a square minus b square. Then 1 into 1 1 minus cos square. From identity 1 minus cos, it will be equal to sine square theta. So here we have square square, we can take common square. Then since in the right hand side we don't want sine and cos, we can break the LCM. We can write it as 1 by sine plus cos by sine. From the relation we know 1 by sine equal cosec, cos by sine equal to cot theta. So square and square get cancelled, which is equal to right hand side. So we prove the equations, the questions.